So we know now that electron configuration is a listing of the subshells and their energy levels that are filled with electrons. And we know that we start with the lowest energy level in subshells, fill each one before going to the next one. And then we also write the number of electrons in each subshell and energy level as a superscript. Now so far we've used our little diagram to help us know the order, because after 3p the energy levels get kind of close. Remember this diagram right here. And so because they're so close, we need a little bit of help to let us know which energy level comes before which energy level and which subshell comes before which subshell. So this diagram has been helpful, but we're also going to look at using the periodic table to help us figure out the order of electron configurations. The periodic table was originally ordered according to chemical and physical properties of elements. However, it also can be looked at as set up according to electron configuration. There are 4 main blocks of the periodic table based on subshells. The S subshell can hold 2 electrons maximum. Our first 2 columns represent the S block. The P subshell can hold 6 electrons. 1, 2, 3, 4, 5, 6. This block right here represents the P block. Now let me just say that helium only has 2 electrons. It really should not be this color. It should be gray. It's part of the S. So the P doesn't start until the second energy level, which is the second period. D subshells can hold 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the D block right here. And then F subshells can hold 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's the F subshell. So here are the different blocks. Now let's take a look at the period numbers. These period numbers are related to energy levels. Here we have our first energy level. In our first energy level or shell, we have 1 subshell, the S, and 2 electrons can fit in it, so we have 2 elements, hydrogen and helium. Our second energy level is represented by our second period. In our second shell or energy level, we have S and P subshells available for a total of 8 electrons. We have a total of 1, 2, 3, 4, 5, 6, 7, 8 elements in the second period. Now the third period, we have the S subshell, the P subshell, and the D subshell. D subshells are always in 1 energy level higher than they actually are. And that's because once we get above the 3p, the energy levels get really close to one another. And the 4s is actually lower in energy than the 3d. So the D subshells are always an energy level less than the period that they're in. So here's our 4th energy level, the 4s and the 4p, we have the 3d. Here's our 5th energy level, 5s and 5p, our 4d is in this energy level, or this period. 6s and 6p, that's our 6th energy level. The 5d subshell is in this period. So the D is always 1 energy level lower than the period it's in. The F's are 2 energy levels lower than the period that they're in. And the F's only occur in the 6th and the 7th period. So in the 6th period we have 4F, and in the 7th period we have 5F. So how can we use the periodic table to help us do an electron configuration? Well, we start at the very top and go from left to right until we end up with our as many electrons as we need for electron configuration. So let's look at an example. Write the electron configuration for potassium. All right, let's find potassium. Here it is right here, 19 electrons. Okay, so where do we start? Well, rather than use our diagram, we use our periodic table and we go from left to right, filling each energy level and subshell until we get to 19 electrons. So this is our first period, this is our first energy level, and the only subshell allowed in the first energy level is the S. So 1s2. So that takes us here. We're done with the first energy level, then we go to the second. Here is our S block, and 2 electrons maximum can fit in the S, 1, 2. Okay, so we've taken care of 4 electrons now. Let's keep on going. This is the P block, and 1, 2, 3, 4, 5, 6. 2p6. All right, we're done with the second energy level. Let's go to the third. This is the third period. So 3s, and this is just 12, so we're going to fill that up with 2, and then go across here. This is our 3p. This is the P block, this is the S block, first energy level, second energy level, third energy level. So this is where we are, just at 12 electrons after our 3s, so we got to keep on going, and 3p6. Okay, now here we are, potassium. This is our fourth energy level, this is our S block, and it's in our first column, so it is 4s1. So anything that ends up here is going to be S1, second energy level, third energy level, fourth, etc. Anything that ends up here is going to be S2. Anything here, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, and then P1, P2, P3, P4, P5, and remember, our P's don't start till second energy level, so they don't start filling, we don't have P until neon. Helium only has 2 electrons, so it can't have any P's. And then here are F, F1, F2, F3, F4, F5, etc. So let's look at another example. Write the electron configuration for copper. Here's copper right here, 29 electrons. Okay, so where do we start? At the top. We have to go fill each block, go from left to right until we end up here. So here's our first energy level. We have an S subshell, 2 electrons there. Here's our second energy level, 2 electrons. Here's our P block, 2p6. And remember, I'm getting those by 1, 2, 3, 4, 5, 6. And at the end of a row, our S and P subshells are always filled. Okay, here's our third energy level. I'm done with my second energy level. Go on to the third one. And I still have more to go, so I fill that up. And then here's my 3p, and they're all filled. When it's filled, I only have 18 electrons, and I still have 11 more to go. So 3p6. Okay, I'm done with my third energy level. Now I'm at my fourth, and I start off with the S block, and that's filled because that only takes me to 20 electrons. And now I have to go to copper. Now remember, our D is 1 energy level less than the period it's in. So this is our fourth period, so this is going to be 3D. 3D 1, 2, 3, 4, 5, 6, 7, 8, 9. And when I count up all my electrons, they add up to 29. So this is how we can use the periodic table to help us figure out electron configuration.